Hi everyone, I'm Shania.
I'm Cassie.
I'm Abby.
And this is our presentation on our guitar peg locks. To begin, our problem statement is that frequent playing and shifts in humidity can cause parts on guitars to loosen over time, especially if your guitar is more on the affordable side and not like those expensive high-quality Fender guitars. Because of this, a lot of guitar players have to retune their guitar after leaving it unattended for a while because they'll come to find that their strings are not the right pitch. And having to tune your guitar a lot can be tedious and disrupt your playing flow. Now moving on to ideation. To understand this issue a bit deeper and check the validity of our problem statement, we have to do a lot of research, including market and patent research, which essentially helps us see if there's even solutions out there for this issue. When conducting this research, we came to find that there are a lot of solutions on the market that work well, but are either too pricey or too complex. So we have also done the defense of the 5 essential questions, where we went into depth about the root causes of this problem to find out what exactly the issue is, who experiences the issue, when it occurs, and why it is worth solving. So as you can see here, there are a few snippets from our defense essay. These ones in particular are answering the who and what question, and as you can see, there are highlighted parts which are the key points. For what our issue is, we learned that cheaper guitars are frequently at the heart of our problem and tend to have looser parts, and humidity is also a factor that plays into those loose parts. And for who faces the issue, we came to find that guitars with varying skill levels face this issue.
Decision making. After doing market and patent research, we then created a Google survey to get input from musicians to see if they face the same problems we do. And based on the responses we got, we noticed that they do and want a solution. After noticing that, we then began brainstorming ideas and solutions to fix this problem. Abby went through more of a mechanical route, which would fix more on the inside of the guitar. I went through more of a locking solution, which would lock the pegs in place, and Shania went through more of a protecting solution, which would protect the pegs once placed against the wall. After sharing all of our ideas, we then put our ideas on a design matrix and picked one design, and although we picked one, we still continued to go our own separate ideas, and over time later on, we then mixed all of our ideas together and tried to create the best product possible.
Now on to the development. For the justification of the solution, we decided on the ideas that we did because of their scores on the decision matrix, but also because they met a set of criteria that we had decided upon. These criteria included the product being smaller than 1.5 inches, that it could be easily painted black, that it would have no sharp edges, that it would be cheap, and that it would synergize well with the pegs. Then we started to CAD the designs because one of the requirements for our project was to make a 3D model of the design in Fusion 360. And this helped our development not only because it helped us visualize the product, but also because it made it so that we were able to change the product really easily, especially because we had many iterations, as you can see. And it also helped because we decided to 3D print our prototypes. And then some of the math that was involved in our product was measuring the dimensions of the peg in order to ensure that the design would both fit over the peg and lock onto it correctly. Without those, the product wouldn't work how we intended it to. And then some of the technology that we utilized was 3D printers and a milling machine.
Prototyping. Here in the picture are all the different iterations we went through to get to our final product, and I'll explain more on the next slide. So for the first prototype, it's made up of a 3D print that Shania already made, taped with some cardboard, and we glued the locking piece to get an idea of what we wanted to make. But then we noticed that we can already have it together in CAD and 3D print it at a PLS or ALS. But then we noticed that this would only work if the pegs were faced in one direction, which is unrealistic. So then we CADed the protecting piece so that it's much wider so that it can fit onto the guitar no matter which way the pegs are facing. But the problem with this one was it would break easily, and that's not what we wanted. So then we tried to mill it out of wood, and although it was stronger, it didn't look the way we wanted it to and took too much time. So we did some more research and found that polycarbonate material was stronger and something we had. So we tried it and found that it was stronger, it worked, and looked the way we wanted it to.
Now on to the analysis of the final product based on our criteria. So for the first test, what we wanted to see if the locks were successful in keeping the guitar in tune by comparing the tuning of the guitar with them and without them. In order for our product to pass this test, it would need to be able to keep the guitar fully in tune, and the tuning of the guitar was measured by both a tuner and by comparing the sound of actually playing it from one day to another. Based on the results of the tests, our product was successful because the tuning remained the same. For the second test, what we wanted to do was measure the durability of the product. In order to test it, we decided to have multiple people repeatedly put on and take off the lock and see if after doing it 30 times, the lock showed any signs of being broken or worn down. We had considered other methods, but since the product is meant to go in a guitar, we didn't think something like a stress test would be appropriate. In order for our product to be able to pass this test, we would need to see no cracks, and we need to still be able to hear the click when it locks onto the peg. After having 3 people test it, nothing broke and the click was still there, so the product passed. For the third test, we wanted to see if the pegs would move while they were deliberately put into situations that would normally force them to move. One of the things that we tried was repeatedly placing it against a wall haphazardly, and in order for our product to pass this test, we would need to see no change in where the peg was previously. After running this test multiple times with multiple people, we were able to determine that the product did in fact work, as there was no movement. And then for the last test, we wanted people to give their opinions on the simplicity and aesthetic of the product, which was one of our main criterias. We used a Google form to collect people's opinions and easily analyze the results of the tests. According to the responses we received, the product passed the test because a majority of the testers voted favorably.
Now moving on to the reflection. Some changes we would make to our final product is explore more options for materials, because we mainly stuck to 3D printing. And another change we would make is making the circle on our locking system a bit bigger so that it's easier to put on and take off. What we could have done better. I personally wish that we would have spent a bit more time learning how to use the milling machine so that we were more prepared for that process.
I wish we did more research on 3D printing materials so we didn't waste time on milling and stuck to a simpler way.
And I wish that we would have focused on the main designs that we were confident in instead of other ones that we were less confident in and didn't even make it to the presentation.
And that's it. Thank you.